And welcome back. We've been discussing theories, models, laws, and hypotheses as they're used in academic fields, including yours, whatever academic field you're in. We have been discussing these in the context of misconceptions and popular misconceptions that people have, especially about theories. And we've also talked about how science and health news are often misreported and misunderstood by the general public. So I want you to first look at these discussion questions. These are some implications of what we've been talking about. Pause the video for a while and discuss these questions with one another, with yourself. What do you think about these questions? Pause and discuss. Okay, implications of all of this. One, when you hear stuff in the news about a new study, says this is good for you, this is bad for you, you have to understand one experiment, one study does not prove something. And maybe the news media shouldn't be reporting that or reporting in that way. You have to be skeptical when you hear this stuff in the news or in social media or on the internet. You have to be skeptical when you hear stuff like this. It's going to take a whole body of research and evidence before the medical community or the scientific community says, okay, this is true, this is a thing. Sometimes when news stories report, a medical or health study, they'll say, what they talk about is, they'll say it like, oh, this causes something. This causes cancer, or this makes you smarter, this improves brain function. And that's maybe not what the original researchers said in their published scientific study. If you dig deeper, you may find this. Maybe the researchers are just reporting a correlation, a relationship between two things, and maybe the researchers are not saying that one causes the other, but the news media often distort this, or social media or the internet often distort this, and they make the claim that X causes Y, and that's not what the researchers maybe are claiming. You have to understand, correlation does not mean causation. Correlation does not mean causation. Just because people were taking this drug and they developed cancer, or they were taking this particular food with this particular chemical or ingredient in it and they happen to get cancer, you need more research and more studies first before we can say, oh, this causes cancer. Correlation does not mean causation, necessarily. Now, there are times when it does imply causation. Let's take climate change as an example. We know that the levels of CO2 have been rising, and at the same time, temperatures have been rising. Not weather temperatures, but climate temperatures over time. Climate temperatures over time have been rising. And we know this correlation from multiple sources. We can measure CO2 levels in the air directly. We can measure it indirectly because we can kind of guess, oh, how much CO2 are factories and cars pumping into the air every year. We have that. And then we've got the temperature data. And this is not just from modern history, but we have ways of measuring CO2 levels in the past hundreds of thousands or millions of years, and from several different sources. Trees and tree rings, ice in the Arctic and Antarctic, and there are several different sources of data. So we have a good record not only of temperatures in the past history of the Earth and CO2 levels, as well as in our modern time. Plus, we have a causal explanation. We know that CO2 is a greenhouse gas. We know we know already that it traps heat in the atmosphere. We know that. That's a scientific fact. It's a greenhouse gas, and there are other greenhouse gases. So we have causal explanations. So we have correlations from many different sources, and we have a causal explanation. We know that CO2 traps heat. We know this. We have a causal explanation. And if you don't believe this, try moving to the planet Venus, Kumsang, where huge amounts of CO2 have caused the runaway greenhouse effect, so that the temperature of Venus is more than 450 degrees Celsius, hotter than an oven. Don't believe that CO2 is causing climate change? Well, try moving to Venus. It's really toasty and crispy there. Why do some pseudoscientific cures seem to work? People wear germanium bracelets or copper bracelets, or they do some kind of really silly new age therapy kind of stuff or stuff. Well, there's mind over matter. There's the placebo effect, ways that the brain, if your brain believes in something, it can influence how you feel. It can even cause some kinds of emotional or some kinds of physical healing. Not growing a new, missing finger or anything like that, but maybe recovering from an illness because of the power of mind over matter. That's connected with the placebo effect. And there are illnesses where people have real physical symptoms that are caused by heavy stress and anxiety. So there are those reasons. There are scientific reasons why pseudoscientific cures might seem to work, because people believe in it. And then if you have a whole crowd, a whole group of people, you and your community, there's a social effect that magnifies it, that magnifies the psychological effects. Now, how can famous experiments be misrepresented by people selling kind of fake products or pseudoscience? Think of Deepak Chopra, if you've heard of him. He's a sort of, he actually has a background as a doctor, but what he does is mostly pseudoscience. He promotes his New Age philosophy, and it's a mixture of kind of New Age spirituality, kind of religious in effect, with things like meditation and kind of other stuff. And he claims that his stuff has an effect, like his faith healing. It's kind of a New Age faith healing kind of stuff. And there are several ways where people like this can misrepresent science. One is that, Deepak Chopra, for one, is famous for talking about his beliefs in spiritual energy and using a lot of language from quantum physics to talk about his spiritual energy. And he has absolutely no evidence for this belief in spiritual energy, but he makes it sound respectable by using a lot of scientific language which is meaningless. And a physicist listens to him and says he doesn't understand physics at all. He doesn't. He's kind of using this language to impress you. It's complete BS. Some people who believe in this stuff, they'll take a famous experiment to say, oh, this proves it. They'll often, one thing is that they believe in the myth that one experiment proves something, and that's not true. It's not the case that one experiment in science proves something, but they'll maybe take one famous science experiment and they'll, as if that one experiment proves something, and they'll misrepresent it. So there are other kind of New Age, people who sell New Age fake healing methods and fake treatments and fake cures based on spiritual energy. We'll talk about like this famous quantum physics called the double slit experiment, which kind of shows that light acts as a wave or particle depending on how you measure it. And they make the unfounded claim that, oh, it's your consciousness that affects whether light acts as a wave or particle. Therefore, you can manipulate and change the world with your mind by wishing or believing in something. You can make things happen, or you can make yourself, feel better, or make yourself heal. And that's complete nonsense. There are experiments that show that light can act as a particle or as a wave, depending on how it's measured, and it doesn't have anything to do with the consciousness of the experimenters. It's an effect that scientists don't quite understand why, but it has to do with how something is being measured, how light is being measured. It's how it's being measured in the experiment, not the fact that there are conscious observers who are affecting the outcome. That's not true. So they misinterpret science and scientific experiments. Let's talk about some other implications. The G5 conspiracy theory. So G5 is the new Wi-Fi standard. There are G5 cell phone towers. And there's this conspiracy theory claiming that G5 Wi-Fi is causing coronavirus, maybe other diseases, and maybe even that's a deliberate conspiracy by governments. And there are pseudoscientific quacks out there who come up with, they misinterpret science to say that G5 is causing their coronavirus. And they'll show that they don't understand germ theory, because germ theory provides us particular ways to test whether a particular virus or bacteria causes a disease. And scientific tests have shown that yes, this particular virus causes COVID-19, this particular coronavirus causes the COVID-19 illness, following the criteria and procedures of germ theory. And these conspiracy theorists might talk about germ theory, but they show that they don't understand germ theory when they do this. Because the virus that causes COVID-19, that's been isolated and shown in labs time and time again to cause COVID-19. You can't do any experiments like that with G5 Wi-Fi waves or cell tower waves. You can't. Climate change, okay, I just talked about climate change. It's been proven true. It is a fact. And any attempts to deny it are based on misrepresenting science. Misrepresenting science. Misunderstanding and misrepresenting what science says about it. Scientists are in agreement that CO2 levels are causing climate change. Climate change poses serious dangers for us as a species and for the world and for the environment. Evolution versus religion. Evolution is a proven theory. It's been proven true. It's fact. It's accepted by scientists as fact. I mentioned the gene sequences, how we have a lot of gene sequences in common. It's not just the amount of DNA, but it's also actual sequences. We have not just DNA stuff that's like 98, 99% in common with our primate friends, and maybe 60% with our fish, and 50% or less with bananas, but it's also exact sequences. The very same genes in a row, the very same sequence of thousands, tens of thousands, hundreds of thousands of genes, the very same sequence in a row. And we have these same sequences in common with other life forms. And again, more of them with closer life forms like primates, like apes, and then kind of less so with dogs, and less so with snakes, and less so with plants. So I understand why some people feel uncomfortable with this for religious reasons. But there are many religious people who are very committed, Christians, for example, who have no problem with evolution. One of the leaders of the Human Genome Project that decoded the human DNA, human genome, is a very religious guy. Francis Collins is his name. Look him up. He's a very religious, very devout Christian. It's also a common misconception that the 7-day creation story in the Jewish Christian book of Genesis has to be interpreted as literal days. They do not. Actually, in the literary context, I'm talking about literature and religious studies right now as an academic person. Just as an academic person, I'm speaking about religious studies and the literary interpretation of this text. In the literary context, those are not 7 literal days. It is using Hebrew poetic devices, literary devices in Hebrew poetry. It is Hebrew poetry. It uses methods of Hebrew poetry, like repetition of words and expressions and ideas. It's Hebrew poetry. That story, the 7-day creation story, is Hebrew poetry. It uses Hebrew poetic devices to convey a very interesting point. And it's not about 7 literal days, not at all. It's more of a structuring device. These are literary structure devices, and they're also used to make a very strong kind of point. Okay, so in the context, in the cultural context, the Jewish people were promoting their religious beliefs, or the writers of the text were promoting their religious beliefs. Contrary to the views of pagan religions, we had complex creation myths where one god created, the heavens, and another god created the earth, and another god made the stars, or the stars were gods, and another god made animals, and another god made plants. And so the biblical creation story comes along and says, okay, God did this and this and this, using the Hebrew, those poetic devices, and altogether makes a very strong statement. It's an attack on the pagan religious ideas by asserting that their God, Yahweh, the God of the Jews, created everything himself. There were no other gods involved. He made everything himself. And that's what the 7 is doing, the number 7 is doing. So even though I'm not religious and I don't agree with it, just looking at it from a literary standpoint, the text is quite interesting. It's very well done. It's making a point in a very creative literary way. It's making a very strong theological or religious statement. And that's what that text is about. You don't have to interpret literally as 7 actual literal days of 24 hours. That actually is against the intention of the text, the literary structure and intention of the text. So there's no reason to write off or disregard evolution, I think, on any rational religious grounds. And I say this as a person who used to be religious and had no problem accepting evolution at the time. So this is something to think about. Maybe some of you want to look into this topic, some of these topics, for your final project. You're going to do a presentation where you kind of take apart a common misconception. Could be the 5G conspiracy theory, coronavirus conspiracy theories. It could be climate change denial, those who don't believe in climate change, or the denial of evolution, those who deny germ theory, don't understand germ theory, those who don't believe in vaccines, who say don't vaccinate your children, all kinds of misunderstandings of science. So those are some topics you can think about for your final project, your final paper. Next time we're going to go into the psychology behind misconceptions and conspiracy theories, and then later I'm going to talk about the politics of conspiracy theories, because I also like politics, and this is kind of relevant to me too. All right, see you later. Goodbye.